Lesson 23, Important Characteristics to Describe. Example 6. The heights in inches for a random sample of 30 men were measured. The following results were obtained. Use appropriate descriptive statistics methods to describe the important characteristics of men's heights for this random sample. So, to describe the important characteristics of data, we need to use words of the problem to describe the three main aspects. That is, the distribution, the central tendency, and the dispersion of the data. Now, the data in this example was men's heights. So, taking the men's heights data for the sample, we can use the TI-84 calculator to help us calculate the appropriate descriptive statistics. To enter the data into the TI-84 calculator, we press Stat, Enter, to get to the list editor. And then we choose a list. Here I'm going to move over to list 2, which is clear, so I could enter in new data. So starting with the first data value, 73.5, press Enter to enter it into list 2. And we do that for each data value, one at a time, entering in the data value, like 69, and then pressing Enter. 72, Enter. 74, Enter. 70.5, 71, 64.5, 69.5, 70.5, 75, 71.5, 66.5, 68, 76, 66.5, 70.5, 72, 67, 72.5, 69.5, 61.5, 73, 75.5, 69.5, 74.5, 66.5, 64, 67.5, 65, 68. Enter. And take care when entering in data, because just making one mistake will give you false results for the entire problem. Now with the data entered in list 2, we can get our statistics by pressing Stat, right arrow to calculate, press Enter to select one of our stats, and then to select list 2 we press second, and the number 2 brings up L2. Pressing Enter, we get our results. The sample mean x bar is 69.817 inches. The sample standard deviation S sub x is 3.673 inches. N, the sample size was 30. And if I arrow down, we can see that x min, the minimum data value, where the shortest person in the sample was 61.5 inches. X max, the maximum data value, where the tallest man in the sample was 76 inches, and the median, MED, was 70 inches. Now, to determine whether we need to use the mean or the median as our measure for central tendency, we need to determine if we have outliers. Outliers are data values whose standard scores go beyond 3 standard deviations from the mean. So, we can calculate the standard score for the minimum and the maximum data value to see if the data extended far enough in the low or the high direction, far enough to become outliers. So starting with the minimum data value, the standard score is calculated by pressing left parenthesis, 61.5, subtract the mean, which was 69.817, close parenthesis, divide by the standard deviation, 3.673. Enter. Here the standard score is negative 2.26, which is an unusually short height for a male because it does go beyond the 2, but it's not extremely unusual because it doesn't get to the negative 3 or lower. So this is not an outlier. The maximum data value standard score is calculated by doing left parenthesis, and the tallest male height in the sample was 76 inches. Subtract the mean, 69.817, right parenthesis, divide by the standard deviation, 3.673. Enter. The standard score is 1.68, which is not positive 3 or higher, so we do not have an outlier in either direction. So, the appropriate descriptive statistics methods which are used to describe the important aspects of quantitative data that contains no outliers would be to construct a distribution table, histogram, or stem and leaf plot to display the distribution of the data, and to calculate the mean to describe the central tendency for quantitative data with no outliers, and to calculate the standard deviation to describe the dispersion of quantitative data with no outliers. So, we've already used the TI-84 calculator to calculate the mean and the standard deviation. The resulting sample mean x bar was 69.82 inches, and the resulting sample standard deviation, S sub x, was 3.67 inches. A good choice to display the distribution would be the histogram, because the TI-84 calculator can construct histograms for us. To construct a histogram, we press second, y equals, to get to the stat plots menu, press enter to select plot 1. It's turned on, so it'll be displayed when we press the graph button. The type of graph is set to histogram. That's the type of plot we want. Down arrow, XList is the data that we're going to use, and we put our data in list 2. So pressing second and 2 will bring up list 2. Enter. Freq, short for frequency, is 1, and that's usually the case in these problems. In this case, each data value that was entered into list 2 was the height coming from one man. Now we need to set up the window. So we press the window button, and now we have to define the x-axis and the y-axis on our histogram. X-min is the minimum value, X-max is the maximum value, X-SCL is the scale, or the amount by which we're counting by. Now the minimum height in this sample was 61.5 inches. The maximum height was 76 inches. Now we don't have to start exactly at the minimum and end exactly at the maximum. We just need to cover a range that covers that entire range of data. So any value that is at or before the 61.5 inches would be appropriate. I'm going to use 60 inches as our minimum value. Enter. X max. Well, the maximum height was 76, but we could just get a value that goes somewhat beyond that. Let's say 80 inches is our maximum. So now we're going to range from 60 as a minimum to 80 as a maximum on our data axis. And then the scale, the amount by which we're counting by, I'm going to use 3. So we're going to count by 3-inch intervals as we go from 60 to 80. Enter. Y-min. The y-axis on the histogram is the frequency scale, and the minimum is always 0, because the frequency is a count. We always start counting at 0, and then count our way up, 1, 2, 3, 4, to the maximum frequency, which we don't know yet because we haven't completely constructed the histogram yet. So a good estimate for the maximum frequency would be the sample size, n, which is the 30 in this case, divide by 2. So 30 cut in half is 15. So on our frequency scale, we'll go from a minimum of 0 to a maximum of 15, and let's say we'll also count by 3s on the y scale. Now to see the graph, we press the graph button, and here's our graph for the histogram of this sample of men's heights. So looking at the resulting histogram, we observe a pattern where the higher frequency is in the center and the lower frequencies are towards the end. And this overall pattern from low to high to low in frequencies is symmetric. That is, we get about the same extension off in the positive increasing direction from the center as we do to the negative decreasing direction from the center. Data that exhibits this sort of pattern is referred to as the bell-shaped distribution. With the bell-shaped distribution, there's generally a certain expected result. So when it comes to men's height, there is a certain expected height that men will achieve, and that's represented by the high frequencies in the center. Most men are around that average height. But there are some men who are much shorter than average, and there are some men who are much taller than average. But you don't see too many of those. That is, there's much lesser frequency of those. So that you don't see too many very short men in the population, and you don't see very many tall men in the population. Most men are around the average height. That is, that's the resulting characteristics of a bell-shaped distribution. So now we could take each of these three results and then use words of the problem to come up with a good description of this sample. For this random sample, men's heights followed a bell-shaped distribution with a mean height of 69.82 inches and a standard deviation of 3.67 inches.